Alright, so lesson 1.4, solving absolute value equations. We're going to evaluate expressions involving absolute values and solve absolute value equations. So absolute value means how far away you are from 0. So the main thing to remember is that if you're here at positive 6, you're 6 units away. And if you're here at negative 6, you're still 6 units away. So the absolute value of 6 is 6, and the absolute value of negative 6 is 6. So here is an example. Absolute value of negative 5 would be 5. Absolute value of 7 would be 7. So we use kind of these bars on either side for that absolute value symbol. So don't get those confused with parentheses or brackets. For any real number a, if a is greater than or equal to 0, then the absolute value of a is equal to a, because it's positive. If the absolute value is less than 0, then that's when it would be that negative a. So model here, for example, if we had negative 4, the absolute value of negative 4 is 4, then we would be 4 units away. And then the absolute value of 4, if we were at positive 4, is still 4 units away. All right, so what that has to do with solving equations is we treat the bars like they're grouping symbols. So we're going to go ahead and plug in or evaluate, plug in 4 for x. And we are going to then simplify within those absolute value grouping symbols. So 2 times 4, we do multiplication first, is 8. 6 minus 8 is negative 2. Continuing to bring down that 2.7. And the absolute value of negative 2 is 2. And then we finish by adding. So our answer should be 4.7. So you go ahead and try that next one. Plug it in, simplify within the absolute value, and then double check your answer when you're ready. So 4 times negative 2 plus 3 in the absolute value symbols. Multiply first. So it would be negative 5. Kind of hard to write here. And that would be 5 minus 3.5, which would end up giving you 1.5 for your answer. All right, let's move on to solving an absolute value equation. So, geometrically, the absolute value is distance, again, from 0. So the absolute value of negative 3 and 3 is 3. Distance is never negative. So a could either be negative 5 or positive 5 if we plug that number in to try and get 5 for a solution. So that's one thing that we want to keep track of, is we could have 2 solutions here when we're going to solve these equations. So our first step is to isolate the absolute value. That's the most important part. So you can't start until one side is just things that are inside that absolute value brackets. Then we're going to set whatever's inside to both positive and negative value of whatever's on that other side. So solving both equations for x, then we would end up with 2 answers. And then we would plug those back in and check and make sure that those were correct. So since this one's already by itself, step 1's complete, we're going to then set up the 2 equations, one equal to a positive 8 and one equal to a negative 8. And then we would just go ahead and solve those as 2 separate equations. So now we get 5 and negative 11, and then we plug it back in to check. So 5 plus 3, the absolute value of 8 is 8. Negative 11 plus 3 is negative 8, and the absolute value of negative 8 is 8. So those two answers do work, and we are done. So try that next one on your own, very similar to A. So you're going to set up your two equations, one equal to a positive 9 and one equal to a negative 9. Equal sign looks weird. And then just solve. And you should get x equals negative 3 and x equals positive 3. And when you plug those back in, it works. All right, notice on C the absolute value is not alone. This plus 5 is not a part of it, so we do need to get rid of that first by subtracting it. So now we have the absolute value alone equaling 9, and we can now do what we did above and set up those two separate equations. And then solve. Divide both sides by 3. Oops, one's positive, one's negative. There we go. So we get positive 3, and then divide both sides by 3 and get negative 3. And then you always want to plug it back in and check, and most of the time you can do that in your head. 3 times 3 would be 9. Absolute value of 9 is 9. Plus 5, yep, 14. And then again, negative 3 times 3 is negative 9. Absolute value is positive 9. Plus 5 is 14. All right. If you want to try that next one on your own, get you started by first step of adding 12. Again, get that absolute value alone. So now we have 8 times the absolute value of 3x minus 10 equals 32. And then divide by 8. Again, getting that absolute value alone. So now that they're alone, we can set up our two equations. So 32 divided by 8 is 4, so 1 equaling a positive 4 and 1 equaling a negative 4. And then go through and solve. Add 10, divide by 3, and you can just leave it as a simplified fraction. So 4 2/3 or 14/3 is fine. Add 10, 3x equals 6, and then divide both sides by 3 to get 2. And then again, plug that back in and check, and it does work. All right. Next, we're going to look at when there's no solution, how that happens. So same way we were solving before, get that absolute value alone. And we have 6 minus 4j equaling negative 5, for the absolute value, equaling negative. Okay, can absolute value ever equal a negative? Remember that the absolute value of something is always a positive number because it's distance. So that's why this absolute value cannot be equal to a negative number. That's when there's no solution. So absolute value of anything cannot equal a negative number. Over here, divide by negative 2. And we wind up with the absolute value of 3a equaling negative 3. Oh, see, absolute value equaling a negative number. That's a no-no. No solution. All right, what is a constraint? Well, we won't get too much into the definitions. If you want to write them, you'll kind of understand once we do an example below, but it's a condition that a solution must satisfy. And we'll look at an example below. It's an equation could be viewed as a constraint in a problem situation. All right, next is going to be an extraneous solution, and that's when the correct procedures for solving are used and the answers aren't solutions. To the original equation. So we work it right, but then when we plug it back in, it for some reason isn't working in there. That's when it's an extraneous solution. So let's take a look at our last two examples here. and see how we would get that. So we'd go through and solve like we did on the front. Absolute value is alone, so we're going to set it up 1 equal to a positive. Well, 1 the way it looks, just without those absolute value signs. And then 1 equal to a negative. This whole side is going to become negative, and how we would do that is just put a negative in front and put the 2r minus 3 in parentheses. And now we would just distribute that negative. So here's my positive. Let's solve. Minus r, add 3, and I'm just quickly solving. Hopefully that's review. 11 equals r. Okay, there's one answer. And then over here we'd work this through distribute first. 8 plus r equals negative 2r plus 3. And then we would add 2r, so we'd get 3r, subtract 8, and get negative 5, and divide by 3 to get negative 5/3. So here's where we plug it back in. When we plug 11 in, we would get the absolute value of 19 equals 22 minus 3. And that works because 19 equals 19. But over here, if we plug in that negative 5/3, we'd get 8 plus negative 5/3. The absolute value, right? Is that equal to 2 times negative 5/3 minus 3? So we'd use our calculator and we would check and see. We get 6 1/3. Is that equal over here? This would be negative 6 1/3. So this side's positive, this side's negative. They're not equal. So this is not a solution. The only solution is r equals 11. So that negative 5/3 is an extraneous solution. So try that last one on your own and then check your answer when you're ready. So first step is to get the absolute value alone. So you'd add g and then you'd divide both sides by 2. And then you'd set up both equations. So divide by 2, 4. So g plus 1, the absolute value of that, equals 2g minus 2. So now that absolute value is alone, we can set up our 2 equations. So g plus 1 equals positive 2g minus 2. And then our other equation, we'll put it down here, is g plus 1 equals negative. And then that whole thing, 2g minus 2 in parentheses. So solving, subtract the g. I like to get rid of the smaller variable. And then add 2. So we get g equals 3. Now we don't know for sure if that's a solution or not, but we'll check in just a minute. Let's do the other one. Distribute. G plus 1 equals negative 2g plus 2. And then we're going to add 2g. And we get 3g plus 1 equals 2. Minus 1, minus 1. So 3g equals 1, which would mean that g equals 1/3 when we divide. So let's plug them back in. So if we took and plugged in 3, it would work. So I'll just tell you that right off the bat. But that's what it would look like if we plugged it in, and we would work through it and double check, and we would get 5 equals 5. So yes, g equals 3 is a solution. And then when we went and tried to plug in 1/3, we would see that absolute value of 1/3 plus 1 minus 1/3, and this is the original equation we're plugging it back into, it does not work. So we wind up with 2 1/3 on the left equaling over here negative 3, and that is not true. So this 1/3 is an extraneous solution. And the only solution to B is 3.